Today, I'm going to show you how to create contour lines at bare earth. I will use DJI Zenmuse L1 LiDAR data. First, I will compare the drone data with GPS survey points. Then, I will demonstrate a workflow from the point cloud to the topographic surface. Stay tuned to hear the entire story. Step 1. L1 LiDAR data. We have an ortho photo that was created from the RGB color values of the LiDAR point cloud. The image immediately reveals there are many trees in my project area. There is also tall grass between the trees. These make it quite challenging when we need to generate contour lines at bare earth. This is even more evident when we disable the ortho photo. You can really see a lot of tree canopies. Let's enable the L1 LiDAR low points data. This immediately reveals some very interesting structures that were previously shrouded by the vegetation. This is a really cool characteristic of LiDAR data. It doesn't only reflect on the top of a canopy. Some laser beams will go between the leaves or grass and reflect on the ground. We are going to use this principle to generate contour lines at bare earth. But let's do a quality check on the Zenmuse L1 LiDAR data first. Step 2. Checkpoints. I have a set of GPS points measured by a registered professional land surveyor. Northing, easting, and elevations were provided. I click Choose Files and load this file. All these points are created at the measured elevation and are independent from the L1 data. I will use these points to check the accuracy of the data. I go to Export and click Checkpoints. The result shows an amazing 5 cm RMSE using the 123 checkpoints. I can even enhance the result by offsetting the elevation model with the average difference. I select the L1 low points terrain, Tools, and I enter 2 cm in the Offset Z field. I check again. Export. Check points. The average error is now 0, and I have a slightly improved RMSE of 4 cm. Now that I am assured on the accuracy, I am going to take you through the entire workflow. Step 3. Low pass points. The LiDAR data doesn't always reach the ground. I have some remaining tree stems, these cars, and the house. But that is okay. I will model a topographic surface under all these objects. I select the project area. I set the point grid type to low pass and the grid size to 1 meter. I click Point Grid. The algorithm attempts to place 1 point about every meter. And again, it will favor the lower areas. Let's have a look. It nicely places points around these trees. The algorithm also searches for the lower points in the grass areas. And the really cool thing about this technique is that it allows me to create a lightweight CAD model. A point cloud is just too large, and pixels are just too difficult for CAD software. I will generate my contour lines from these low pass points. But I'm not there yet. Step 4. Cleaning up the low pass points. The 1 meter grid size is too small to allow the points to land off the house. I will need to remove these points. I can use Erase to remove them one by one. But I want to go faster. I hold Shift and select all the points in this rectangle. Delete. I also do this over these small crossings. Delete. I clean this one as well. Delete. I enable the ortho photo again. Low pass points missed the high points on this road, and I need those to model the road crown. Let's solve this. I enable polyline drawing and enable the contours terrain lens. I click here and here and here. These visual contours help me trace through the highest points of the road. I click here and right-click here to complete. Then I go to Tools and I densify the line at 1 meter regular intervals so that my point density is in line with the low pass grid size that I decided earlier on. I repeat this for the other road and the driveway. Now I'm ready to create the contours. Step 5. Contour lines. From this moment on, it is very simple. I click Triangulate All. This will generate a tin from my low pass points and lines. When I look closer, I see that the triangles nicely go under the remaining surface objects. Then I display the tin surface as contour lines. I click Show Contours and Hide Tin, and I set the interval to 10 centimeters. Let me enable the elevation terrain with the tree canopies. You see that the contours nicely go under the vegetation and around the house. Also, the road is modeled well. But how accurate does the tin surface match with our ground control? Let's do the check again. I disable the image terrain and select the surface, and click Modify Terrain in the Tools tab. This will reshape the terrain to the created tin surface. Then I enable my checkpoints again. Export, Checkpoints, and I get a nice 5 centimeter RMSE here as well. I'm now ready to export my contour lines. I go to the Export tab and click Export Survey. I open the final outputs in a CAD software. Extra. Contours from DJI P1. I have here an orthophoto and elevation model generated from a DJI P1 photogrammetric sensor. First, let's do the quality check. I get an RMSE of 8 centimeters for these checkpoints. With the LiDAR, I had 4 centimeters accuracy. This makes sense because we have tall grass on the property. Low pass points at a 1 meter grid size show a lot of points on the tree canopy. We have no information under the tree canopy with photogrammetry. A 1 meter grid size would require a lot of editing. A better choice is to work with a 5 meter low pass grid. Even then, I will still have some points that I need to remove. An easy way to do this is by displaying the surface as a terrain. I hide the orthophoto and surface. The points that stand out can be found easily. I use Erase to clean this up. With the 5 meter low pass grid, the roads are not surveyed correctly. I solve this by adding brake lines at the sides of the road. Finally, I triangulate and display the surface as contours. I change to the 2D view and hide the points. The contour lines are ready. And the accuracy? I enable the checkpoints and get an accuracy of 8 centimeters. Does that mean photogrammetry is not accurate enough? Certainly not. It all depends on the application. When I only use the checkpoints on the hard surfaces, I get a good 5 centimeter RMSE as well. And the photogrammetric orthophoto? Well, it is superior compared to the LiDAR RGB derived one. The details that you can observe from this orthophoto are just mind-blowing. Now, I want to hear from you. Did you validate L1 LiDAR data? Did you use the Virtual Surveyor Checkpoints tool? It's available in the free Valley version. Drop your findings in the comments below. Also, make sure to subscribe to the YouTube channel and get notified about our latest releases. Or explore one of our other videos that will help you work productively with drone surveying.